Good morning, guys. Today we are going to start talking about substitution, which is a different way of solving a system of equations. So the people in school today are going to be reviewing this first. So I'm going to do one quick problem of reviewing how to solve by graphing. So the first thing I would do is look at the y-intercept, put a dot on 2. Then my slope is 3. So I would go up 1, 2, 3 to the right 1. If I wanted to go backwards, I would go down 3, left 1. Down 3, left 1. Okay, now I'm going to grab my ruler, straight edge, and I'm going to connect my points to make my line. My next one, I'm going to start at the y-intercept. It's also 2. My slope is -5, so that means I have -5 over 1 for my rise over run. So I'm going down 5, right 1. Okay. And I'm going to connect those points. They actually intersect the two lines right at that y-intercept because they both started at 2. So this is my point of intersection, which means it's my solution. So I have to name that point, which it is 0, 2. Once I name that solution, I'm all set. This is just some practice solving equations. So simplify the following. Simplify 4x if x equals 2. So I would just plug in 2 for x. 4 times 2 would be 8. Here, if I simplify 3x minus 2, when x is -7, I'd plug in the -7. That would give me -21 minus 2, which is -23. So this is just practicing on the original idea of substitution. When we use the substitution method, however, this is just a little blurb about the substitution method. In addition to solving a system of equations by graphing both lines, we can also use the substitution method. It does exactly what it says. You'll substitute one equation into the other to find the value of one variable. You'll then use that value to solve for the other variable. So what does that mean? Let's explain with a problem. So this you'll have a copy of on Classroom, which will be nice to have, especially if you have a printer at home. I'm also going to print it, so I'll give it to you on Wednesday just to have. Ensure that at least one equation has one variable isolated. So if you look at this original system, that y is isolated. So we're good to go with number 1. If we weren't good to go with number 1, we would have to get that variable isolated. Then we're going to write the other equation, leaving enough space for substitution. So I'm substituting. This is equal to the y. So I'm going to take this and plug it in for y in the other equation. So by leave enough room, I mean you want to put 2 parentheses. And inside that parentheses, you're putting in that expression that's equal to y, just like they did here. Then you're going to distribute this 2 and simplify to get -4x plus 8. And then you would solve this equation for x, and they got x is 2. Once you've solved, you can then move to step 6, which is to substitute the value into either original equation. I like to say original because sometimes we alter equations. So they look like they chose the first one, y equals -2x plus 4. We know now that x is 2, so they just plugged that 2 in for x and solved for y, and they got 0. So then they have your x and your y, and you have to always write your answer as an ordered pair. Okay? So now that's their quick example. I'm going to do an example here. So if I have these two equations, the first step is I want one of them isolated for a variable. I have that. Y is isolated here. So this 15 minus x is equal to y. So I want to take it and plug it into y in the other equation. So I'm going to write down this other equation, and I'm going to leave room for my new y. So instead of putting a y next to the 3, I'm plugging this in because this is equal to y. Okay. Now I'm going to simplify. So the 4x comes down. This 3 needs to distribute. So 3 times 15 is going to give me 45. And 3 times -x is -3x. Now I'm going to combine like terms. So 4x and -3x combines to be x. And then I'll subtract 45 from both sides. So 38 minus 45 is going to give me negative 7. I got that x is negative 7. I found one variable. I still have to find the other. So I need to look at one of my original equations. I'm going to take the first one, y equals 15 minus x. And now I'm going to plug this new x into that equation. So y equals 15 minus negative 7. Notice I put parentheses there because I'm plugging in a negative number where I already have subtraction. So I need to change this. This is now a double negative, so I need to change that to a positive. So y should equal 15 plus 7, which is 22. So now I have an x and a y, so now I have a solution. I have to write my answer as an ordered pair, x comma y. So my answer would be negative 7 comma 22. That's my solution. Okay, let's do another problem. If I look here, and if you need to slow this down at all, feel free to use the pause button. This one is solved for x, so I do still have a variable isolated. So I'm going to take this and plug it in for x in the other equation. That's substitution. So I'm going to write down this equation, leaving room for x, leaving room for that substitution. And I'm plugging this negative 9 minus 4y in where x would be. Now I'm going to simplify by first distributing. So that's going to be negative 18 minus 8y, bringing down the negative 3y and the 4. Now I need to combine like terms. So these are like terms. They have the same variable. Okay, so the negative 18 can come down, and negative 8 and negative 3 combine to be negative 11y. Now I want to get y by itself here, so I'm going to add this 18 to both sides. I have negative 11y equals positive 22. So now my last step to solve for y is to divide by negative 11, and I get that y equals negative 2. Because 22 divided by 11 is 2, and a positive over a negative is a negative. So now I've solved for y, I also want to find x. So I'm going to choose one of the original equations. I'm going to go with this one, the first one. I'm plugging in this negative 2 for y. So I have negative 9, and I have negative 4 times negative 2. That's going to be positive 8. Negative 9 plus 8 is going to give me negative 1. So now I have an x and a y. I want to write my answer as an ordered pair. X always comes first, and then my y. So this would be my solution. See how I'm doing on time here. Doing okay. Sorry, I can only screencastify for so long. So, all right. Now this is the last problem I want to do here. This one's a little different. And what's really different about it is that both of the equations are already isolated for a variable. So these are both isolated for y. Now, if both of those expressions are equal to y, then they must be equal to each other. So I can go ahead and set those two expressions, x minus 1 equal to negative x plus 5. That's the same as me saying y equals y. They are equal to each other. They're both equal to y, so they're equal to each other. Now I can just very simply solve this for x. So I'm going to add x to both sides here. So I have 2x minus 1 equals 5. And then I'm going to add this 1. So I have 2x equals 6. And my last step would be to divide by 2. And I get that x is 3. These are my favorite type of substitution problems because you just set them equal to each other. It's quick and easy to solve. Now, if you were choosing your own method, you'd probably graph this because they're both in slope-intercept form with that y isolated. But in this specific problem, I'm asking you to use substitution. Now, you have that x is 3, so we can plug it into any either of these original equations. So I'm going to choose the first one. And I'm just going to plug that 3 in for x, and I get that y is equal to 2. So my solution should be 3, 2, always putting that x first. Okay. Now this is super important, this part. So we're going to solve 2 more problems, but some interesting stuff's going to happen. So this is equal to y. So I'm going to take it and plug it in for y in the other equation. So I'm going to leave some room to plug it in. I'm plugging 2x minus 3 in for y. I'm going to distribute, so I have 4x, and then 2 times negative 3 gives me negative 6. Okay, you can see here now that both sides of the equation are the same. I still could try to solve this. If I subtract 4x from both sides, my x's are going to cancel on both sides, leaving me with negative 6 equals negative 6. So what happened here is my variable variables canceled. So they disappeared. But what happened is I ended up with a true statement because negative 6 is equal to negative 6. So how many solutions does this have? This has infinite solutions. If you end up in substitution canceling out your variables and getting a true statement, it's infinite solutions. When graphed, what does infinite solutions look like? So think back to a week ago when we did graphing. That looks like one line overlapping. Okay. Now this problem, I'm sure you can guess what this one's going to be. We're going to take this because it's solved for x. So x is isolated, and I'm going to plug it in for x in the other equation. So I'm going to leave some room, and I'm plugging in 8 plus 4y for x. I'm going to distribute this. 2 times 8 is 16. 2 times 4 is 8y. And now I have 8y minus 8y, so those cancel, and I'm left with 16 equals 6. That's not a true statement. So my variables still canceled, but here I had a false statement. Here I had a true. So if I get a false statement like 16 equals 6, 16 does not equal 6. So that is no solution. What does no solution look like when we graph? It looks like 2 parallel lines. No intersection. Okay, so that's just a quick discovery of what can happen with substitution if we get no solution or infinite. Now, you are going to do this problem right here. Okay, try that on your own. Okay, I'm going to pause this quick, and then I'm going to show my answer. So you should pause your video now, and then you can check your answer on mine. Okay, hopefully you got a chance to try this problem and paused. What I got here is 2, 7. So I plugged in this expression for y. I solved and got x equals 2. Then I plugged it into my first equation. 3 times 2 is 6 plus 1 is 7. Okay, so you guys are going to do some practice today. Hope you have a wonderful Tuesday.